I wanted to do a quick recording here to go over the syllabus and the way the course is set up in general. I was hoping to have done this on Thursday when we met, but as you know, we had problems with the projection system and internet access, which we'll get squared away for next week. All right, let's. I'm up on Canvas right now. Let's take a look at the way the course is set up. I'm going to click the syllabus over here on the left. Oh, and also you can see I'm in student view, so I'm seeing what you see. So I'm going to click syllabus here. It's a PDF file. Let's open it up. Let's take a peek here. Okay, let's see. As you know, this is EGR 223. My name is Gordon Snyder. Just call me Gordon. And we've got Bob Greeny, who is doing the lab. I'm handling the lecture. The lecture is done online, remote, and Bob is doing the lab, which meets Thursday afternoons, 2 to 4:30. Okay, our class meets, from the 20th, the week of the 20th to May 14th, and again, the lab is 2 o'clock to 4:25 on Thursdays. The textbook is required. It's the Engineering Circuit Analysis book by Haight. It is available in PDF. I've got it linked up as a PDF on the Google Drive. We'll take a look at that in a little bit. It is the 8th edition. It's not the most recent, but this stuff doesn't change. Okay, it's an introductory electrical engineering course. It hasn't changed in 20 years. Some of the ways we approach the problems have changed, but the actual content itself has not changed. So equipment, you're required to have a computer. As you know, we did this in lab on Thursday. You need a Windows computer to run PSpice. The additional software will be using the ADLMs. That'll run on a Mac. So hopefully this next lab will get some of that stuff installed. If not, we'll get it installed when the next time I am in lab. I am remote. I'm doing some consulting work in different parts of the country right now, and I do have some travel coming up. So I'll be on and off as far as Thursdays go. All right, course description. You can read that. This is right out of the HCC catalog. Learning objectives, you can take a look at that stuff. It's primarily a DC course. We do some reactive inductance and capacitance stuff excuse me, at the end, and but it's primarily 90%, let's say, DC, direct current. So and that's typical. This is the same course that's being taught at most of the universities in the United States right now. Prior to HCC, I was at University of Central Florida, and I was at the University of Hartford teaching these courses and advanced courses, advanced electrical engineering courses. So I have a pretty good idea of what should be taught in this course, and I have a pretty good idea of what you need to know as you take the more advanced courses. You'll take courses on transistors. You'll take transistor courses, for example. You'll take a communications course. You'll take an electromagnetic fields and waves course if you're an electrical engineering major. I've taught all of these courses at the university level in the past. So I'll get you where you need to go, and if you work hard in this class, I think you'll be in good shape for your transfer to university. There's different instructional objectives here. The course is chopped up into 5 sort of units or segments. You can take a look at these. The first one's current, voltage, and power. That's where we're working on now, and it just continues. There's some more. Unit 2 is Kirchhoff's current law, Kirchhoff's voltage law, etc. You probably don't know what these are now, but you will in a few weeks. Unit 3, Thevenin and Norton. Unit 4 is op-amps, operational amplifiers. It's interesting, this op-amp stuff is always placed in this course. When I was taking electrical engineering courses, op-amps were actually 2 separate courses. It took a full year of operational amplifiers. Now they kind of condensed it down into about 3 weeks of this course. something I'll never understand. Op amps are used all over the place, but they're kind of like almost like television sets now. You sort of plug them in, and as long as they're working, you leave them alone. If they stop working, what do? You throw the one that's not working away and you replace it with a one that is working. So it's been an interesting thing. And then the last 3 weeks or so of the course, we'll do RL, RC, and RLC circuits. Okay, those are resistor, inductor, resistor, capacitor, resistor, inductor, capacitor circuits. So we'll take a look at some of that stuff. There's different laboratory skills. I'm big on laboratory stuff. It's not something you typically get a lot of at a university, but you'll come out of this class hopefully with some good experience, a good hands-on experience when it comes to the lab work. Each lab, once we get into them, will be set up as a in 3 parts, I guess. You know, you'll get a circuit, you'll do some hand analysis, basically hand calculations, pencil and paper. You'll simulate with PSpice, then you'll actually build a circuit and take measurements. So each step kind of reinforces what you're learning, okay? As far as homework and classwork goes, I'll be honest with you, I'm not sure about homework. I've been thinking about this a lot, and you want to make sure you do it, but it is so easy to do now with AI. If you haven't used Gemini, try taking a picture of one of those homework problems, asking Google Gemini to solve the problem, and you'll see what I mean. You're probably already doing that. At least I've been doing it for a while. So homework has become kind of useless. So we'll try to get some quizzes in. The labs are an important piece. The exams are important. I am going to add a oral component to the exams where we'll get on Zoom maybe each 5 to 10 minutes and we'll just talk our way through a circuit. I just want to make sure you understand. You know, one of the most important things you're going to learn in this class is you're going to learn how to determine whether something is in series or parallel. It sounds really simple and really basic. When we get into it, you'll see. You're going to say, what are we learning this stuff for? But this is what's going to help you the most when you get to your advanced classes. Being able to look at a circuit and figure out what's in series and what's in parallel. The math, like you'll see in some of my lectures, I use the term DSM, do some math. When I was in school, the term was by inspection. I hate that term. I have nightmares about that term because I remember my professor saying it all the time. But it's do some math. The math has become sort of secondary, and with tools like MATLAB, and also I'll get you all set up with licenses for MATLAB. The college does have a site license for that, so you can use that. But Google Gemini to me is one of my favorite tools when it comes to doing math type problems now. So the math has become pretty I don't want to say it's secondary, but the math has become it's the easy part, I guess. Okay, it's just changed, and you know, I'm trying to make adjustments in this class to get past those changes or get beyond those changes and get to a point where we use AI as much as we can to solve these problems. But it's important for you, again, to be able to look at a circuit and make a determination. What's in series, what's in parallel? How is all this stuff connected? Okay, if something's not working, why is it not working? Is it because of the way the circuit is built? Is it not built properly? Is one of the components bad? One of them something shorted or open circuited? So these are the kinds of things I want to try to focus on with this class, and you'll see how it goes. I love feedback, and good, bad. You know, if I'm doing something that's not working or it's really driving you nuts and you don't understand it and it doesn't make any sense, I want to know about it. Okay? No question is a bad question. All right, attendance. You're expected to, you're going to do about maybe 5+ hours a week for the course. and you want to make sure you use your time wisely. And that 5+ hours per week is for the lecture content. And you got what, 2.5 hours of lab each week. So it's, it's a good 7.5, 8 hours a week figure when you combine in the lab. Here's how your grade is broken down: 20, 20 for exam 1 and 2, 25 for final exam. Homework and quizzes. Like I said, I'm right now I'm leaning towards not collecting homework, but I hate to do that because it's important for you to do the homework. Okay, but as I mentioned, it's pretty easy to do now with AI. So the quizzes are an important part. We'll try collecting some homework and see how that goes. Okay, 10% labs. All right. As far as my availability goes, gsnyder@hcc.edu. I no longer have an office on campus, so I don't have a telephone number extension. But I imagine you could contact Bob, and he can always get in touch with me if something happens. As far as my availability goes, I plan on doing a Zoom session, and I'm thinking, we talked a little bit about this during the lab on Thursday. I'm thinking I will be available Thursday afternoons. I know some of you work evenings. Evenings probably isn't a good idea, but I'll make myself available either in person or online on Zoom. Let's say Thursday afternoons 1 to 2. I think that makes sense. And then if we got to do something a little more than that, we can figure that out. Academic misconduct, you can read that. That's right out of the excuse me, the student handbook at HCC. Security for Zoom sessions, recording of help sessions. Okay, typically what I do is I like to make videos. If somebody has a question, if a couple of people have the same question, usually I'll crank out a quick video on a homework problem or something like that. If you do have an accommodation, please let me know privately, and we will work around that. As far as the library goes, I think everybody's got a computer now, which was good. It's good that you got them early because those of you that needed a PC, because I think they're all gone now. Course outline, you can, excuse me, I'm getting over the cold here. You can look at this. This is what we're going to be doing. Lab reference, there's a bunch of lab stuff, and again, Bob is handling the lab, but this is stuff I've put together. You can take a look at this stuff, okay? And then labs, Labs 1 and 2, computer application installations. We got Spice going, and that was good. I was happy to see that. I think everybody has it going right now on their computer. Everybody's got a computer that needs one, and we're good with that. So depending on next week, we may or may not do the ADALM Scopy software installation. I'd like to try to do that, but again, I won't be there, so we'll see how that goes. Then we get into some of the different labs. I've got 15 labs here. I think I mentioned last class, or in lab. Typically a university program, you're probably going to do 5 labs in this course. Some of these labs are pretty basic, but they require you to understand how to use the equipment. And they require you to actually build a circuit, make the proper series parallel connections. I keep them stressing that over the course of the semester. And so that's what's important here. You're learning how to build things, you're learning how to take measurements. I'd like you to be able to look at a circuit and say, oh, that doesn't make any sense. I got this much voltage going in and I got this much voltage over there. What the heck's going on? So those are the kinds of things. It's almost by doing a number of labs, basics, more simple labs like this, I think you learn intuition, I guess, and that is really going to help you when you transfer to university. Now, what else do we have here? I think that's it. What else do we have here? Yeah, that's it. So that's the syllabus. Now let's take a look at the way the course is laid out. All right, and I'm going to just click week one. Each week I will post basically a document similar to this, another PDF. All right, so what do we got? We'll be using Canvas to access all course and lab materials. All lectures have been recorded and available following this link. I don't know why I can't. I made this link hot, but it is not hot. So I'm going to grab it and copy and paste it. Okay, this is up on my Google Drive. This is the whole course right here. Okay, if you look, Chapter 2. We're going to start with Chapter 2. Chapter 1 is just an introductory chapter. We're not going to spend a lot of time on Chapter 2. When we get into some of the more later chapters, we'll spend more time because there's more content there, and it takes longer to learn this stuff. So don't think, okay, week 1, Chapter 2, week 2, Chapter 3. And this is something that I've only got week 1 listed right now. I'll list week 2. Probably Monday, Sunday night, Monday, and I gauge each semester. I teach this; it's a little different depending on how we're doing. Okay, if we're stuck on some stuff in Chapter 3, we may take an extra week on Chapter 3. Okay, so every semester is a little different, and I try to make adjustments for the class, if that makes any sense. But let's look at Chapter 2. Let's open this folder up. Okay, there's 5 videos here. 1, 2, 3, 4, 5. And so that's all of Chapter 2. Those are my lectures, my recorded lectures for Chapter 2. I've also got a PDF here. And this is the full set of notes. There's 15 pages here, you can see. Again, introductory. Chapter 2 is more introductory. But take a look at this. You can go through this. Basically, this is the exact PDF. This is the content that's recorded in those videos. So you can take a look at it. So you can download it. You can watch the video. You can make notes on this, however you want to handle it. I do like making videos here. I do like teaching this course this way. You can see here I use different colors. I try to use different colors when I can, which to me works out really nice, and I do this on the iPad. For the Zoom sessions, I can link up my iPad, and in the Zoom session I can do the same thing. Like if you got a problem, if you have a question on a homework problem, we can get on a Zoom session and work through the problem together, and I can basically do it on the iPad. Okay, so take a look at this stuff. Make sure you understand this stuff. If you have questions, you let me know. That is weird. Some weird stuff going on here. It's like hieroglyphics. I'll have to see if I can fix that. But there's part 5, and I have each one labeled. So this is where Chapter 2, Part 5 starts. So it's set up that way. I hope that makes sense. It's worked really, really well in the past. Okay? Let's back up a little bit here. What else do we have here? I've got some other material, some supplemental material. Complex numbers are big now at the university. I think I mentioned on Thursday, Laplace transforms are no longer taught at UMass Amherst. They still are taught at places like University of Hartford, Western New England University, and University of Central Florida, but they are not taught at UMass anymore. We've seen this shift to complex numbers. So I got a little supplemental on that. The text is here. The full PDF is here. You don't have to buy the text. This is free. We're not doing anything illegal. The 8th edition has been made available by the publisher, so we have access to that. All right. What else do we have here? We've also got some, I've got a few homework solution videos here, not much yet, but I'll be posting up. There's some other supplementals, inductance supplementals, some lab stuff here. Other texts for references, maybe take a look at this. Okay, if let's open it up. Okay, this engineering circuit analysis book here is a separate textbook. This is the book that's currently used by Western New England University and University of Hartford. It's a good book. It's just as good as the Haight text that we're using. Haight text is UMass text primarily, but you have access to it. Okay, you got a PDF of each. Free. Again, these are free. These are made available. They're free. We're not doing anything illegal by using them. And then we've got this book right here. This is an old Floyd text. And the Floyd text, there's no viruses in it. I'm not going to open up. It's going to take a while. But this is it's an engineering technology textbook. So what it does is it describes things a little differently. Okay? It's non-calculus based is probably the best way I would describe it. But if you're having trouble understanding something, you can grab this PDF, you can do a search on it. You know, one of the really nice things Floyd does is complex numbers and imaginary numbers and circuit analysis, RLC circuit analysis using complex numbers. So it's a little different approach. It goes a little deeper into some topics. But again, connectivity, Floyd stresses a lot on connectivity. And I like this book as a reference book. I like this Floyd book as a reference book, so you can take a look at that. What else do we have here? PSpice, we already grabbed that. But the PSpice zip file that we installed last class is here, or lab on Thursday is here. So that's laid out, I think pretty basic. And this is someplace that you're going to be going for this class. Again, everything is here. Okay, the entire course is here. I've got some labs. I've only got the first lab set up because I'm going to be making adjustments, but I've got all these labs done. I've got a whole bunch of labs. I got about 30 labs put together for part 1 and part 2 of this course. We're only doing part 1 this semester. So we got a lot of labs, and labs to me are a lot of fun. For me, I tend to learn, I think, better in a hands-on kind of environment. And again, that's the stuff that's really going to help you when you transfer. All right. What else? So we went through the syllabus review. We talked about the textbook, lecture, lab materials. We installed PSpice on Thursday. This week you want to watch the Chapter 2 videos. And here's the homework problems right here. All right. So work on these. You should have tried all of these before lab on Thursday, week 2 lab on Thursday. And that'll be a time to ask questions like, I'm stuck on question 31. Can you help me out? You know, those are good questions. Okay, the first quiz, I'm going to try to have a quiz every, oh, and the homework will be due on February 5th. So it's not week 2, the homework will be due week 3. So typically what I'll do is I'll assign homework, like now, assigned homework on week 1. Okay, you'll have week 2 to ask questions on the homework, and then week 3 it'll be due. So I don't want to assign homework and then collect it without giving you an opportunity to ask any questions. It'll be due February 5th in class. If we collect it, and I'm thinking I probably will, maybe I'll just do a check mark, or so I'll check it off or something like that. But I want you to do the homework. It's important you do the homework. And then we'll have a quiz. And the quiz is going to be based on that homework. So the first quiz will be on February 5th. It's going to be a quiz similar to the Chapter 2 homework problems. So hope that makes sense. So that's kind of where we're at. What else can we say about the course here? I'll post the labs here too. We did PSpice Lab 1 already, but I'll post the second lab up also here. Probably should be posting these as PDFs, not docs, but I'll take care of that. Get it installed on your computer. We talked about PSpice and how that works, and what these numbers mean, voltage, current, and power. And we'll be using PSpice quite a bit. PSpice is the one of the primary tools that electrical engineers will use. Um, what else? Let's go back here. Oh, as far as announcements go, I will post up announcements as needed. Each week I'll post up an announcement linking to, or at least describing what we're going to be doing this coming week. Discussions. I mean, I'm not big on discussion forums. You can put stuff in a discussion forum if you want, but I've never had much success using them in class, and I would rather have you ask me a question, especially a course like this where there's a lot of hands-on and a lot of problem solving. Okay, it's much easier to jump on a Zoom session and get my iPad going and work our way through a problem together. All right, I think that's about it. That's the way you can see the way the course is laid out. And if you have any questions, let me know. I will not be there week 2 Thursday, not in person anyways, but I will be available by Zoom. I'm going to say 1 to 2 p.m. Or no, I'm sorry. The lab meets 2 to 4:25 p.m. So 2 to 3 I'll be there. I'll get on Zoom. I'm not sure I'll be able to get on a projector or not, but you all have computers and you can all join in if you have any questions. I'll work with Bob on getting the lab, figuring out what we're going to do for lab on week 2, and we'll go from there. So please let me know if you have any questions. I hope this all makes sense, and really looking forward to the semester and getting to know you all and getting you through the course. And if I can help with internships or resumes or transfer stuff, just let me know. Okay? Thanks.